Now, I want to go over low voltage breakers for a little bit. You're going to find that when you're doing a power system, there's more low voltage breakers in your facility, unless you're a fused facility, than any other type of equipment. And so we need to go look at how we're going to enter that data. If I left mouse double click, here is my dialog box. Remember, we start out with the spec tab. Now the first option we have in this are the different classes of low voltage breakers. They include low voltage power circuit breaker, insulated case, and molded case breakers. And we split those up per the NEMA UL classifications because there's probably 50,000 breakers in this library. We go clear back into the 1940s and we have all sorts of the different manufacturing options. And so there's just many breakers. So in order to keep it so that the user can find them easily, we break it up into those classifications. So if you choose a low voltage power circuit breaker class, when I hit the breaker manufacturer drop down, it's going to show all the different manufacturers that make low voltage power circuit breakers or have made them, including ABB, the old Alice Chandlers, Brown Boveries. A lot of these people are even out of business, but we have those in there because there's a lot of legacy systems out there. So this goes back, even with the old Roller Smiths, the old Westinghouse and things. I'm going to grab something that we all know about, let's say a General Electric. Now when I pick the General Electric manufacturer, then over here in the type, it sorts all the GE manufacturing information. Here's from the 1940 A series, the 1950 AL series, the 60 and 70 AK series, the 80 and 90 AKR series, their new Wave Pros, Impact IECs, and so on. I'm going to pick something that we're a little familiar with, let's say AKR series. When I pick an AKR, I come over to the breaker style, and notice that there's the AKRUs, there's the AKRTs, the S's and L's. There's many different styles. What you need to do is look at the nameplate on your particular breaker, and it's going to say something like AKR50 or a K-frame or something, depending on if you're choosing molded case breakers or not. Now, when I pick an AKR50, what's going to happen is it automatically goes to the library. It looks up in the library for an AKR50. They came with a GE Microversatrip PM solid state trip unit for low voltage power circuit breakers. Now all you have to do is pick the sensor and the plug rating, and now we have our device detailed in full except for the trip setting. So there is how we input data for a low voltage breaker. Now if this is a breaker only, we could have a fuse breaker such as an AKRU or a breaker contactor also, and these graphics will morph depending on what you choose. Now what I did is I went through the theory so that you can see how that is actually done. What I want to do is show you how you would do it in a practical sense. We wouldn't go through the theory each time. We just hit find style. It would come up with a find button. We type in AKR, hit find, select AKR 50, and we're done. Now, low voltage breakers are the only type of equipment that you need to input three tabs worth of data. The second tab, or the short circuit tab, all you have to do is hit the calculate button. We automatically verify the short circuit rating based on the voltage of the system. And then the phase trip setting tab. So the phase trip setting tab shows several little red dots. That means we've entered a phase trip. Now we need to know what those settings are if we're going to analyze it properly. And obviously if we're doing this from an actual going out collecting data standpoint. So this is a legacy system. If we were doing our automated design routine where we're doing a greenfield system and we're designing from scratch, it would select all this for us and we wouldn't even be inputting data. So I'm going to tell it what we want for a long time pickup. We'll just pick an easy number like 1, a long time delay setting. Now all these different settings, you can only enter the data that is on the nameplate. So you cannot, it's not going to give you a continuous setting or anything. It's only going to give you certain discrete steps based on what's on that nameplate or that device. So same with delay, min, max, interrupting, intermediate. Now, if you ever have any questions as to what all this information means, you can always hit the help button. We'll just pop that up. You can always get a detailed dialog box information. We can scroll down and say, I want to find out more about phase trip settings for solid state devices, and there it gives us all the details about how we collect data and what every field means. Now, there's several more tabs we want to go through. There's a ground trip setting tab. So if you want to plot a ground, say you're doing a full-blown protective device coordination study under NFPA 70E Article 410.9, we'd probably model the ground system also, as well as the delay here. Now, fuse setting. If this was an AKRU with a fuse, we could model a Faraz Shamet, AB4Q, say an amp trap, AB4Q fuse with a 1600 amp size, and we're off and running. Now I'm going to uncheck that because we don't need that model right now. And say if this was a molded case breaker with an overload for a motor, we could model in detail the overload rating integrated with the breaker instantaneous trip, say a GE CR124Y with a fast or a nominal type device. Now when I hit OK on this, it is going to put in my breaker information, and now we have that described in full. Now if this was a switchgear lineup, you can see that we have 6 other breakers on these feeders. So how are we going to input that data? We obviously do not want to do it one at a time. If you left mouse click and highlight that device, you could go up to the toolbar, hit the copy button, and the cool thing about this is EasyPower was the first power system program developed ground up in Windows and C++. After 17 years, it's still the only program developed ground up in Windows and C++. All of the functionality is just like Microsoft Word or Excel. You do not have to learn anything new. A copy is a copy, a paste is a paste. So then I could come over here, left mouse click, come back up here, hit the paste command, and we would copy that in. Now obviously, if you remember when we were talking about that to begin with, that's 2 times up to the toolbar, and I just wasted 10 seconds worth of work. So if you're a Windows Power user, you could Control C, left mouse click, Control C, that's copy, Control V, that's paste. Most people aren't power users. So what we're going to do is we're going to introduce our third option, right mouse click. And we right mouse click for everything. So when we do that, we get a context sensitive menu. We can copy. We can right mouse click over here. We can paste. And now I have an identical breaker pasted in. My mouse stays in the middle of the screen. I wasted no time at all. Extremely efficient. Now I left mouse double click on this. I change this typically to an AKR30 because it's probably an 800 amp censored breaker with an 800 amp plug. My short circuit changes, and I could set the automatic calculate button on so it would do this for me. You don't have to hit the calculate. It just makes it a little easier to explain things when I'm doing this. I change my phase trip settings to whatever happens to be on that device. If it has a ground trip, I change my ground trip settings, and then I'm off and running. So there's my AKR30. Now we don't want to do that for each one of these breakers, so what I'm going to do is right mouse click, copy. Now remember, the left mouse click, press slide release, right mouse click, paste. My mouse stays in the middle of the screen. I just created a switchgear lineup in a couple mouse clicks, and that's how easy it is to operate in EasyPower.